Hi guys, today we'll be discussing a little bit about case airflow. The sample I have right now is the P400, very popular case with the tempered glass. It's got two air intakes, or two main air intakes, one over here and one at the bottom down here. Okay, of course you have another large intake area at the top, but most of the intake will be from the front because I've got three fans. It has one at the top here, one at the center here, and one at the bottom. Okay, this will be, I would guess, quite a common configuration for air intake fans, and I think this case can represent quite a lot of popular cases today, like the NZXT, S340, even all the way up to the Corsair 460s, the 570X, etc. So let me just show you my airflow configuration using this thing. Okay. It's just a metal wire with a very thin strip of toilet paper that I've cut out. Okay, you can focus. Alright, I've just stuck it there with a little bit of blue tack, or rather this is the white version. I'm going to put it up here, and you can see it's quite a bit of air suction going on over there. Alright, I'm going to bring it down to the bottom. Okay, so you can also see very strong air intake. Okay, in fact, let me change up this to something else. I've made this thing, alright, a very simple contraption using a toothpick and of course the tissue paper, or rather it's actually toilet paper. It's lighter. Okay, then I've got this styrofoam box cut out, so you can see I move this away a little bit. The paper isn't moving. Move it closer, it goes straight up. Alright, so I'm just gonna leave this there so they can see. I mean, we will do a comparison later, but this is my current airflow. And for the top, I've got this one, 3 toothpicks, and we're just going to put it up here, put it close to it. You can see straight away the paper moves up. Okay, I move it away, move it towards it, the paper moves up. Okay, so I'm just going to put this over here and leave it there. Okay, I've got blue tack at the bottom too. Alright, so this attached. Okay, so this is my current configuration. Exhaust, I just have another fan there. Alright, it's a Cooler Master fan. Let me try to find the... Okay, this is the Cooler Master Blade Master 120. High airflow, and the most important thing is high static pressure. So at maximum RPM is about 3.9 mm H2O. CFM is 76.8 CFM at max RPM, plus minus at 2000 RPM, plus minus 10%. Okay, so I've got two of these fans. One is pointing at the back, and the other one is at the center. It's the center fan over here. Alright, so everything is at idle. I'm not running anything. Okay, on my AI suite at the bottom you can see, okay, my voltage is about 1.318 times about 41 here. Speed 3.7 gigahertz. Okay, so this is basically my setup. Now, let me just run a simple Cinebench, and then you have a look at the air movement from the top first, then I'll move below. Okay, it's running really hard now. Okay, the fans are You can feel the fan. Let me move this away. Okay, there's quite a bit of airflow going on right now. Go to the bottom. Move this away. Move it closer. Wow, they're really dancing. Okay, let's have a look at the back. A lot of air being pushed out. A lot of air. Okay, go to the top. There's actually something very interesting happening. Quite a bit of air is actually getting sucked in from the top. So Cinebench is over. It doesn't look like it's moving much now. Let's move this away. Okay, I'm gonna leave this there. The bottom one is still moving quite hard. Okay, move this away. Now there's a reason why the fan, or rather the air speed from the intakes are so strong. Let me just do something. I'll remove the front casing. The current configuration is like this. I got fan filters in the front. As you can see, they're really dusty. This is just 1 week's worth of normal activities, like doing some work, some gaming, and I've got this much dust. Now, let me take out one of the dust filters. This is from Silverstone. It's a really fine mesh filter, and it's caught quite a bit of dust. Now I have gotten rid, or rather I've taken out this is the default, or rather the stock filters from the front of the case that comes with the case. I'm just going to compare size of the filters. Okay, focus. Okay, can't really capture the filters. Let me try on a white surface. Okay, so this is the stock filter. This is my filter. It's so fine you can hardly see it. Okay, let me try to bring it up again. Stock filter comparing with the Silverstone filter that I got. You can see this one, stock filter, and this is the ultra fine filter. A much better filter medium, I would say, given my very dusty environment. Okay, so this is why I got this. The other reason is the two filters that come with the case. Okay, if you put them at the bottom and you compare side by side, look at the surface area. It's about equivalent to just one filter. So if I'm using this case for a week, chances are these two filters, they're going to be clogged up, and then that will affect my airflow. So I'm going to see temperatures in my CPU rise for, well, basically no reason whatsoever. Okay, so it's better in this case to remove this filter and put up your own if you have a dusty environment. Okay, I'm going to talk a little bit more about airflow, but it's going to take some time. I'm going to open up the case, then I'm going to use this contraption, and I'm going to move around the CPU cooler plus the area behind the fans, just to give you an idea about the airflow. Alright, okay, so I'll be back in a while. See. Hi guys, I'm back. I'm going to show you some of the interesting discoveries I had over the past couple of days while fooling around with this contraption prior to this actual filming. 3 fans for air intake. Oops. Top fan is a stock fan from the Phanteks case. This one is the Cooler Master Blade Master. The bottom one is the also the stock fan from the case. Now let me do a comparison of the airflow. The 3 fans are all at 60%. So you can see there's quite a bit of air movement. Now the case is open right now, so don't be alarmed by the seemingly weird airflow that's going on. Look, it's actually pointing up. It's quite ridiculous, but that's just some air turbulence going on. Okay, this is the bottom fan. It's actually blowing downwards, but actually it's blowing towards the case. Sorry, towards the CPU cooler. This is the bottom fan, and very weirdly you can see the tissue paper is actually sometimes finding its way into the fan. Now this is an open case scenario, so when the case is closed, it's gonna be a little bit more interesting. Okay, so this is the area in front of the CPU cooler. No surprises there. Same with the area behind the fan. I'm not gonna go too close because the last time I did that, the paper just went into the fan. Okay, now somewhere at the top of the case, you notice that the paper is actually trying to find its way into the CPU cooler. Now that's cause I have a push-pull configuration. I'm gonna pull this fan out later so that you can see the difference between a push and a pull combined. Okay, you can see the paper is getting drawn into the CPU cooler here now. Okay, just a quick recap. Now the bottom, a similar scenario, but you have this GPU fan that's blowing upwards, so that's interfering a little bit. Let me try to mitigate that using an envelope. So put an envelope here, and you can, don't know whether you can see this, but actually let me lower the camera angle a little bit. I gotta tilt this sideways, sorry about that. You can see the paper is getting drawn into the CPU cooler. Same thing. Okay, so I'm going to tilt this back. Now, give me a couple of minutes. I'm going to or rather second in video, I'm going to remove this fan, and then do the same thing and show you the air movement above the CPU cooler. Alright, something interesting. Be back soon. Hi guys, we're back, and you can see the pool fan has been removed, and it's just a push from configuration right now. Everything is still running as stock. I'm not running Cinebench or anything hard on the CPU. And let's just have a look at this CPU airflow again. So in front of the CPU cooler, that's what you expect. Let's move a bit closer to the top, and you can see something very different. There's actually air. Notice how the paper is pointing upwards. You can actually see air getting pushed upwards. There's a lot of air escaping from the top here. Let's move a bit closer. You can see what I mean. Can you see that? In other words, this gap here, this portion, you're getting a lot of air being pushed out by the fan upwards. So it's not really going through. You have 4 heat pipes. So my worry is that the front fan is just touching these two, okay, or the area where all these fins are. Okay, this front fan is basically cooling these two. All right, it's a U configuration, so basically just 2 heat pipes. The other 2 at the back definitely benefits if you have a pull configuration by pulling the air through. Now the case is open right now, so I can't really show the. It's not fair to show the stock and load temps. Okay, but another thing I want to show is this. Right in front of the rear fan, as you would expect, air is getting drawn in. Air is getting drawn in from the top. Okay, I want you guys to take note of this. So even if I put the fan, put this paper very close to the fan, it's getting drawn in. Alright, this is the effect. Any angle I put it in, the paper is getting drawn into the fan. Okay, especially here. Now I'm going to change this rear fan to the stock fan that came with the case. This is a airflow fan. This is a static pressure fan. This is somewhere, this guy is somewhere in the middle. Alright, high static pressure fan. I'm going to change it out, and then you're going to see for yourself the difference in the air movement with an airflow fan. Now, the issue I want to bring up is because of this grating. This grating actually impedes the airflow out of the case. So by having a static pressure fan, you're actually able to push more of the air out compared to a normal airflow fan. And you're going to see in my example later, when you put the stock fan here, the air is actually going to be bouncing off this grill area. Alright, give me a minute, I'll be back again. Hi guys, I've done a little work here, which is to replace the rear fan, okay, to a high airflow fan. And I'm going to show you something that I discovered a couple years back when I first started my own PC building, and that is this. Now I've got this contraption back, this tissue on a metal rod, and let's have a look at the airflow. Now, I've taken out the pool fan on the Cryorig cooler so that I got more space to work with, and show you something now. This is a high airflow fan. I'll show you the specs later, but have a look at this. This is an open case right now, so it's no surprise that you're gonna see a lot of air being pulled in. I'm gonna push the fan a little bit further in. Alright, I'm gonna push this rod a little further in so that you can see the airflow. And if you can see right now, instead of the tissue being sucked in, it's actually pointing upwards, which means at the edge of the fan, air is being pushed away from the exhaust grill. Okay, so air is not being pushed out of the case totally, but if I move this one down, then you can see, yes, the tissue is actually pointing towards the fan. But if I move it a bit further up, higher towards the edge of the fan, there's a lot of turbulence, and you see the tissue actually pointing away from the fan. Now I'm going to explain this strange phenomenon in a while, but let's have a look at the specs of the fan first. Okay, this is an AeroCool fan. Let me turn around to the screen. I've already put up the page so you can see the specs clearly. This is an AeroCool Shark fan. It is a LED fan. The version I got is a blue LED because my old PC build, the focus was actually blue. Okay, go further down. The number of blades on the fan is 15. Alright. The design is to maximize airflow, and it has a FDB bearing, FDB fluid dynamic bearing, which means you can orientate this fan any position, horizontal, vertical, pushing air out of the case, pushing air into the case. Anything is possible. There's a reason why fluid dynamic bearings are better than sleeve bearings, which are the cheapest fans out there in the market, and it's actually the fan, the type of fan that comes with my case, the P400, the Phanteks P400. Okay, let's go further down. You'll see the specs. Alright, max RPM is 1500. Okay, this column is the standard connection, power mode. This column shows voltage reduction cable, silence mode. Voltage here is 12, over here is 7. Let's go further down. RPM 1500, 800. This is the airflow, very impressive. 72.6 CFM, 32.5 on the other side. Air pressure 1.273. So this is an airflow fan, and you notice that in a lot of literature, I don't know, by fan sellers, they tend to say that rear fans, you can just use an airflow focus, airflow oriented fans for maximum airflow out of the case, to push air out of the case. But as you can see earlier, let me bring this back. As you can see earlier from my example with the tissue, air is actually being pushed away from the edge of the fan. Okay, you go further up, you see it's pointing up, it's pointing up, it's pointing up. Okay, there's a reason behind that. Let me bring this fan back. Let's have a look at the design of the fan. I've got another fan here, so you can see this is 15. This fan has 15 blades, very impressive, a lot of airflow. But there's a gap, there's a very wide gap here. Alright, and because the air pressure is, well, I won't say it's very low, it's 1.273, pretty respectable still, but it's not as high as the my current configuration, which is using the Blade Master from Cooler Master. Okay, the air pressure 3.9 mm H2O, airflow 76.8, not too shabby, just slightly off compared to the 82.6 CFM. Now going back to this fan, this is not pressure optimized, so there's a bit of back pressure against the grill. So imagine my fingers being the grill. There's a lot of back pressure hitting the as air goes through the fan and hits the fan, the exhaust grill, and is being pushed back. As it is being pushed back, these gaps, this gap between the blade and the frame is actually allowing air to shoot out in this direction. Okay, it's shooting outwards, which is why we saw the tissue flying out. Now at the center, we don't have this issue because air is actually being pushed outwards, hitting against the frame and coming out this way. Coming out this way. Alright, but because there's a back pressure, something is preventing a smooth exhaust of the air. Is pushing out. Excess air is getting pushed out, which is why you get this turbulent effect from the tissue example you saw just now. By itself, it's not a big issue. Actually, it just means that you're not getting the full airflow. If you're maxing out the fan, you're not getting the full airflow out. So in your own calculation of positive or negative air pressure, you got to take that into consideration. There's going to be backflow. Another problem is that if you use a sleeve bearing fan, there's going to be a lot of vibration as the air is being pushed out. At the same time, it's trying to be, well, the blades are trying to force air through, but air is actually being pushed out at the side, at the edge of the frame. So that causes a lot of fluttering. There's a lot of vibration going on in the fan. Two things will result: noise due to the turbulence, and number two, it's going to create a lot of vibration to the fan hub. Over time, it's going to cause the fan to actually have all these clicking sounds, wobbling or kickling sounds, which whatever you might call it, but it's basically gonna be noisy, irritating the hell out of you. This is basically due to a lot of vibration due to the fan blade. Alright, which is why my default exhaust setup is using a pressure fan. So if you are thinking of using an airflow fan, airflow centric fan for your exhaust, think again and maybe consider using pressure focused fans. Alright, so I'm going to switch this exhaust fan back to my original my Blade Master. So we'll be back later. See ya. Alright guys, and we are back, and as you can see, everything is back to normal. My 3 fans are installed. My Cryorig is working happily. Spectrum setting right now. And if you haven't figured out by now, this whole PC setup is based on a positive airflow model because of the amount of dust that's in my room. Not so much just my roof, but in fact, just asking any of my neighbors, they'll tell me, they say that their house is dusty all the time. I'm not sure why this is the case in our area, but we do get quite a lot of wind from just about every direction, from the south, from the north, from the southeast, even sometimes from the west. So pretty dusty in our area, and that's why I need to have all these additional measures on top of what the case offered. Now, this is by no means a put down to this case. This is a fantastic case. In fact, I've built, I think, four PCs using this case, 2 whites and 2 blacks, and everybody loved this case. Okay, it's just that my environment required additional measures. And if anyone is thinking of getting a cheap, no, I won't say it's cheap, relatively good mid-size case, this is the one to go for. One additional thing I didn't show was at the back, just below the the power supply, there's a pull-out filter. So that actually is a fantastic feature. Most cases of this price range, they'll just give you a filter that is similar to this, which is on top of the case, but you got to slide it into some slots at the bottom of the case, which makes maintenance really troublesome. Okay, so this is the end of the video. I'm just going to give you a little bit of a teaser the next video I'm gonna do, and that is for vibration. This case actually has average vibration features. There's a lot of rubber as well as a foam padding in these screws, okay, for the tempered glass, but at the base of the case, the legs, you don't get actually a very good rubberized foam. It's just a very simple, very thin layer. So I find that when the fans ramp up, this case actually sends a lot of vibration down to the table, and when I'm using my mouse, you can actually feel the vibration. Not a very ideal feeling, so I'm gonna change that up a little bit with a couple of stuff. 2 things. This one, it's called an earthquake resistant mat. Basically, it's just a very bouncy, I can get a material name. Oops, I fell down again. Okay, cut. The material name, I can't pronounce this. Thermoplastic polyurethane. Okay, so this one is 3mm thick, soft, quite soft. Okay, it's earthquake resistant mat. Alright, I've got another one. This is thicker. They call it a shock proof pad. It can support up to 35 kilos. It's 5mm thick. Okay, so this blue one, I'm gonna put at the base of the case, just at the feet. And for this one, I'm gonna put them where the fans are, attached to the case, around this stretch where the case is actually in touch with the fan casing. All right, in addition to where the screws are, I'm gonna try to put it on this side, on the two sides. Okay, here too. All right. There's nothing that I can put on a horizontal bar, but I'm gonna put it all on the vertical side, as well as where the screws are holding on to it. Okay, so I'm gonna give a review of these two items. It's not easily found just anywhere. I bought these at Daiso, which is a $2 shop in Singapore. I imagine there are quite a few other outlets elsewhere in the world. Online, it's pretty expensive. I think on average, $6 to $10, $6 to $10 US per pack, and it's just this pack, okay, which I got for $2 Sing. It's 2 Sing dollars, which is about $1.45 US. So I'll give a review of this one in the next coming video. Meanwhile, thanks for watching. Take care. Bye.